In this video, we'll be looking at Chapter 15, Section H, on the parallelism of vectors. Now remember from the last video that we were looking at scalar multiples of vectors. Well, it turns out that if two vectors are parallel, then one of those vectors has to be a scalar multiple of the other. So to represent that two vectors are parallel, we use the parallel symbol, which is two vertical lines that are parallel. And as I just said, if I have two vectors that are parallel, then there must be some scalar k, and that k, or that scalar, has to be a non-zero number. It can't be zero. There has to be some k, at least one, that makes this expression true. Vector A is equal to scalar k times vector B. Now the converse of this is also true. If I have an expression of vector A that equals scalar k times vector B, then vector A and vector B must be parallel. Remember that vector k still has to be a non-zero, scalar k still has to be a non-zero scalar. Here are a few other things to consider. If k is greater than 0, then the scalar k times vector A has the same direction as vector A. And if k is less than 0, then k times vector A is the opposite direction of vector A. And if we want to find the length of k times vector A, we can simply find the modulus of k. Your textbook uses the word modulus, and we know this as the absolute value of k times the length of vector A, which we discovered how to do in a previous video. Let's take a look at an example here. We have two vectors, vector A and vector B, and vector A has the components 6 and 3, and vector B has the components 2 and 1. By simple inspection here, we can see that vector A is equal to the scalar 3 times the components 2, 1. Which means that vector A is equal to 3 times the vector B, 3 being our non-zero scalar. This means that vector A is parallel to vector B. And if we were to draw them, and this is just a simple sketch, not to scale, but it would look something like this. Now, just to further prove the point, let's find the lengths of these two vectors. So we want to find the length of vector A, and remember from a previous video that we're really taking the square root of each component squared, or the sum of each component squared. And in this case, this simplifies to the square root of 45. Which I can further simplify to 3 times the square root of 5. And for vector B, we have the square root of 2 squared plus 1 squared, which is indeed the square root of 5. So notice that the length is really being multiplied here by the scalar. Notice that A is 3 times the length of vector B, and the directions are exactly the same. In this example problem, we're asked to find t, scalar t, given that vector A and vector B are parallel. And we're given vector A has components negative 2, 6, and vector B has components t, negative 12. To solve this problem, we need to remember that if two vectors are parallel, then one is a scalar multiple of the other. And in this case, I'm going to multiply vector A by a scalar to get vector B. Now, since our x component for vector B is an unknown, let's start with the y components. In this case, I need to find k, I need to divide the y component of B by the y component of A. And that gets me negative 2. And I can check that because if I multiply the y component of A by negative 2, I get the y component of B. Now I multiply the x component of A by the scalar, or scalar k, and they both happen to be negative 2, to get the x component of B, which in this case is t. So t is equal to positive 4. Again, I can quickly check that by multiplying my x component of A by the scalar, and we can visually see that this makes sense. I'm multiplying both of these components by negative 2 to get the other components for vector B.